Hello student, in this video I'm going to start or starting the discussion, continue the discussion from the last video. That is, we are discussing about time series analysis. So here you can see the objectives of time series analysis. So first point is that we need to understand the dynamic or time dependent structure of the observations of a single series. It is univariate analysis. Univariate means one variable, means that one variable, the observation of a single series, single variable, how it dependent on the time, or what is the dynamic behavior of that of the time dependent structure, or we can say observations of a single series or single variable. And also second objective is that forecasting of future observations. We can forecast the future observation having the understanding or having analyzed the dynamic or time dependent structure of observation of a single series. Third one is that ascertaining the leading, lagging and feedback relationship among several series. Also here you can see we can understand, or we can be sure about, or we can observe the leading or lagging, means if there are more than one time dependent variables associated with in a single series, or single means in one series, if there are more than one variables and they are related, then one might be leading, one variable might be leading, one variable might be lagging. And what are the feedback among them, among those related variable uh, in that series where several variable might be there. So that several series, or we can say as a whole multivariate analysis, or multiple variable which are dependent on time, and we can understand, or we can ascertain the leading, lagging and feedback relationship among those several variable. So in case of time series analysis, we can follow these steps. First, we need to identify the model. Uh, Time series, plot of the series. First, we need to plot the time series, or you can say we can plot the observations with respect to the time, and check for existence of a trend or seasonality. So we need to find the trend or proper pattern, whether it exists or not in the time series, or it might be, there might be some seasonality or some frequency or some pattern might be there. So check for the sharp changes in behavior. We can check, or we need to check for the sharp changes in behavior in that trend or in that pattern. Check for possible outliers in the data, or in the time series analysis, or in the time series curve or plot. We can found, or we can check the possible outliers, means which do not, or with the behavior of some values or variables does not go with the trend, then it might be outlier. And second one is the remove the trend and seasonal component to get stationary residuals. So by removing trend and seasonal component to get stationary residuals, means some specific constant or errors might be there, or some different behavior, or that what we can say is that what is the difference between the actual value and the trend value, that might be the residuals. And we can get that residual or that stationary residuals by removing the trend, and or by removing the seasonal components. Third one is that third step is the estimation. Here two name is mentioned here, MME, MLE. We'll go through the full form of this in next slides, or in after few slides. The fourth one is diagnostic checking, normality of error terms and independency of error terms. And also third one is constant error variance. So we can go for diagnostic checking of the time series, that is about normality of error terms, means what is the behavior of the error. Is those error are independent, or is those error have some dependency, and what is the normal value of this error terms. Can we measure the normality of that error terms. And also constant error variance, means is there any relation in the variance, is there a variance of the error. And Last one is forecasting, exponential smoothing methods or minimum MSE forecasting. MSE means minimum square estimation, or you can say that is the point. Exponential smoothing methods or minimum MSE forecasting. You can go for forecasting the data in for the future. So here you can see some characteristics of a series. For a time series yt, here you can see yt for t equal to 0 or plus minus 1 and plus minus 2, that it will go on. So what is the value of yt? So in the time series, the mean function mu t equal to e of yt. E means expectation of yt exists if and only if expectation of yt less than infinity, means the expected value of the process at time t. The variance function sigma square equal to equal gamma naught, or equal to variance of yt. So variance is variance of yt, which is equal to expectance of square expectance of this yt minus mu t, the difference between actual observation value minus the mean value, and the square, that is the square, and that is expected value, and equal to expectation of this minus mu t square, which is should be less than infinity, and this should be greater than equal to 0. Total variance should be greater than equal to 0, and this should be less than infinity. The autocovariance function, here you can see yts, covariance between the value at time t and the value at time s of a stochastic process yt, means how they variate, or simultaneously how that two value, means at different time, is there any covariance between two values at time t and times s. We can measure that using this function, where yts, or you can say covariance function, autocovariance functions, that is equal to covariance of yt comma ys at two different time point equal to expectation of yt minus mu t, means what is the value of that at that point minus mu at that region, the mean value of that at that t time or t duration or t range into ys, that is the actual value at s point, and minus mu of s at that time, that will be multiplication of these two, and which would be under the expectation, and that will be give us the covariance. Or we can say, if we multiply these two factor yt and ys, it will be expectation of yt and ys minus mu to mu s, because mu to mu s cannot be under expectation, mean value is directly constant, but expectation value might be variable, and that is why it is under the function. And here you can see ts equal to 0 plus minus 1 plus minus 2, which will be go on as it is time series. So this is the covariance between the value at time t and value at time s. And also there will be autocorrelation function, the correlation of the series, this is rho ts core CORR core correlation of yt and y is equal to, this is autocovariance value here ts divided by sigma t and sigma s, that is deviation sigma t and sigma s, that will give us the autocorrelation value of two value, the value at time t and value at time s of a stochastic process yt, and minus 1 less than equal to rho ts and plus 1. So that values would be between minus 1 and plus 1. Here you can see moving average process, let exist some t for that between 0 and 1, xt equal to expected t plus 0.5 expected minus 1. This is not complete enough, so we'll go through next slides. Here what you can see, let e1 e2 be a sequence of So here you can see let e1 e2 be a sequence of random variables with zero mean and variance sigma square. The observed time series yt equal to t equal to 1.12, that it will go on, t that value will go on to n, is obtained as y equal to e1 and y2 equal to e1 plus e2, and that is, you can say that y equal to y1 plus e2. So in that way, this is random because this is just a random walk. Y2 is dependent on y1 plus e2, and y3 is e1 plus e2 plus e3, means y3 equal to y2 plus e3, and y1 yt equal to, that is why yt equal to yt minus 1 plus e2. So that is what random walk means. E1 it will be a sequence of random variables with zero mean and variance sigma squared. A rule on the covariance is that if C1, C2, Cn and D1, D2 and Dn are constant, and T1, T2, Tm and S1, S2 till Sn are time points for respectively, means for this part T1, T2, Tm are the time points, for this part these are the time points, but these are the constants. Okay, these are the constants. So but the values are different, but with respect to those time. So here you can see covariance of the first part, I equal to 1 to m, means 1 to m, ci constant 1 to m, then yti means whatever variable of that observation will get at time t1 or t2 or tm. So that is the first part. That is second part with the time points s1, s2, sn, because j equal to 1 to n, j equal to 1 to n, dj is d1, d2, dn, and ysj means y for this time points, value of y or value of that variables or observation at for these time points serially from 1 to n, and covariance of both two series for different time points equal to summation of continuous summation of, in summation of I equal to 1 to m into continuous summation of j equal to 1 to n, means it is a nested summation, ci dj, multiplication of ci dj constant ci dj into covariance of yt I comma ysj, and we can get this covariance from the previous equations, um, or we can say covariance variance of this one equal to summation of y1 to m ci ti equal to m I equal to 1 to m ci square variance of yt, plus this is any variance, means for any variance value will get this equation, plus this is the first part where I will m ci square constant square variation of yt I, plus twice this is summation of I equal to 2 and j equal to 1 to I minus 1. So this is the rule on covariance. Joint PDF of a time series probability density function, fx1 x1 the marginal CDF, fx1 x1 the marginal PDF. So this is the time joint CDF, this is the joint PDF. For the observed time series says we have 2 points D and S, the marginal PDF, or you can say probability density functions fyt yt and fys ys, the joint PDF. fyt ys yt of ys not equal to fyt yt into fys ys. Here you can, since we have only one observation for each random variable yt, inference is too complicated of distribution or movements, and changes for all t, that is changes over time, so we need a simplification. So we'll try to go for the next slides in the next video, and again this whatever content we have gone through in this video might be complex one, or if you have any confusion or question, please let me know. We'll try to resolve that. Thank you.